Alright, hi class. I'm going to try something new and make videos for you guys. I know that right now you're probably finishing up chapter 3, so I thought what I would do is I would go into the book. This is at the end of chapter 3, and we're looking through some of the review exercises. I might not go through all of these, but I'll definitely go through some of them. I even found this cool little calculator app that I downloaded. That way I can work through something in the calculator with you all as you run through it yourselves. Now your version of the calculator may be a little bit different, but that's okay. I'll also try to split up this video. I don't want it to be super long, so maybe I'll do it in like 10-minute chunks or something like that. But here we go. We're just going to jump right into it. So you will definitely have questions like this on the upcoming test, the chapter 3 test, and of course on the midterm and the final exam as well. So muzzle velocity. The following data represent the muzzle velocity in meters per second of rounds fired from a 155 millimeter gun. There's just a bunch of times here. Or sorry, not times, speeds. A, compute the sample mean and median muzzle velocity. So first off, this is a sample, right? It's just a collection of 10 different velocities. It's definitely not every single velocity possible from this gun, just a sample of 10. You could easily find the mean and the median doing this by hand, but this class is not about doing stuff by hand, or at least I don't want it to be about doing it by hand. I want you to be able to find the answer however you figure out the easiest way to find the answer. And your calculator can do almost everything by itself. So what we're going to do is we're going to go into the Stat button of the calculator here and then Edit. So when you do that, you should come across this table. Now I'm sure some of you have already played around with this. If you somehow deleted some of the columns up top, I do want to show you how to fix that. If you go into Stat, and then Setup Editor, hit enter there, and then just hit enter until it says done. That'll fix your table. So if you go back into it, it's all cleared out now. So I'll show you how to clear it out the right way without deleting the columns. So what we're going to do is I'm going to pause the video here and just type in all these velocities. You don't need to watch me type all that stuff in. Okay, so I typed all of in. If you want to pause it and type it into your calculator, then of course do that as well if you want to kind of follow along. Now that I have all of the raw data in this first column here, I'm trying to find the mean and the median. I'm going to go back into Stat, arrow over to the Calculate menu, and then this first option here, the 1 VAR Stats. When I do it, I get this nice little menu. Some of you may have the menu, some of you may not have the menu. If you do have the menu, just make sure the frequency list is empty because we have no frequencies in our table here, and that your list matches the list that you typed all the data in. I typed it into L1. Then just go down to Calculate, and it should give you everything. So it gives you this X bar that represents the sample mean. Another important thing is rounding. You always want to round your mean to one extra decimal point. If we all have tens place here, we're going to round this to the hundreds place. Now it's already in the hundreds place, so that is going to be our sample mean there, the 7092.51. And then the median we get just by arrowing down a little bit. So here our median, 792.4. And then that's it. So that's going to be our two answers there. The mean, which was the 792.51, and then the median, the 792.4. Okay. Part B, compute the range and the sample variance. So I got my little thing here, my OneNote that I can draw on. For part B of this question, the range is not something that the calculator can do. This is something you have to do by hand. But it's very easy. To find the range, you just take whatever the maximum value is. It looks like that's 794.4, and you're going to subtract away the smallest value, which looks like 791.4. Yeah, I don't see a smaller one. All right, then when you subtract those two things, you can just subtract that in the calculator, but that comes out to be 3. So this has a range of 3. Okay, it's also asking us to find the sample variance and then the sample standard deviation. I'm going to leave it in the same menu because you can get the standard deviation from this same menu. It actually gives you both. The S is the sample standard deviation. The sigma here is the population standard deviation. Because we have a sample and because it's specifically asking us to find the sample standard deviation, we're going to grab the S from the calculator. We're rounding this to 2 decimal points because this all has 1 decimal point, so we're going to have a standard deviation of 1.42. So we have a standard deviation, little s, 1.42. The other thing it was asking us to find here is the sample variance. The sample variance is just whatever the standard deviation is squared. So just square that. If I go back into the calculator and do the 1.42 squared, 2.02 is going to be my sample variance. I think that's the easiest way to find the variance, is just to use the calculator to find the standard deviation and then square that to get the variance. Okay, cool. But that's it for that one. I'm going to skip this question 2 because it's the same thing. Let's move on. Following data represents the ages of chief justices on the Supreme Court when they were appointed. A bunch of old people. Determine the population mean, median, and mode, the range and the population standard deviation, and then this is just asking us to get a sample size. We don't need to worry about that. You're not going to be asked to do that on the test, is to obtain random samples, so that'll be okay. But again, this is the same thing that we just did. Safety tip of the day. Just type all of these into the first column of the calculator, do that one VAR stats button. That'll get you the mean, it'll get you the median. The mode is something you're going to have to do by hand, so just figure out which one of these numbers shows up the most, and keep in mind there may be 2 or more that show up the same number of times. And then the range you have to do by hand. The population standard deviation, that would be the sigma in the calculator. So I'm skipping over this one because it's the same kind of thing. 4. So it gives us a bunch of raw data here for the number of tickets that students got. Then it's asking us to draw a frequency histogram. So that's going back to chapter 2 stuff, and describe its shape. Based on the shape of the histogram, do you expect there to be, do you expect the mean to be more than, equal to, or less than the median? Determine the mean and the median, and to determine the mode. So this question is very important, although it's not really asking what I wanted to ask in this. What I wanted to ask is, based on the shape of the distribution, which is the better measure, the mean or the median? So let's kind of just quickly map out what this histogram would look like. It looks like I have a ton of zeros here, so this is just a rough sketch. But the zeros would go very high. I have quite a few ones, but not nearly as many ones as I have zeros. Looks like I only have like 1, 2, so that's going to be very small. So this distribution, if you remember from section 2, is right skewed. With a right skewed distribution, let's talk about where the mean and the median would be. The mean is something that does not really get, the mean is something that gets skewed a lot. We call that something that is not resistant. So because the mean is not resistant, even though I have my big hump here, the mean is going to kind of come down the tail. So the mean's going to be over here closer to 1, the mean, x bar. The median, on the other hand, is resistant, which means it is not going to come down the tail. The median is going to stay closer to the top of the hump. So maybe the median would be about there. So here the question is asking, like, which one do you expect to be more than the other? The mean is definitely going to be bigger because the right skewedness is going to pull that mean up the tail. Now, when the question is asked which one is the better measure of central tendency, the better measure of central tendency for this question is going to be the median because it is skewed. If it is skewed left or skewed right, choose the median. If it is a bell curve or if it is symmetric, choose the mean. Okay, other than that, just type all these into the first column of the calculator and you can get the mean and the median very easily. Let's move on. Oh, I can't use my finger for that. Okay, these are really cool questions. So let's look at these questions, this empirical rule thing. I will say that Chebyshev's inequality stuff, I don't want to say that. I don't think it's on the test, but just in case, you might want to just kind of double check it. So let's look at number 5 here. 5A. So just reading through it, suppose that a certain brand of light bulb has a mean of 600 hours and a standard deviation of 53 hours. Part A, a histogram of the data indicates the sample data follow a bell-shaped distribution. According to the empirical rule, 99.7% of light bulbs have lifetimes between what 2 numbers? Anytime you have a question like this where it's talking about empirical rule, you'll know it's empirical rule whenever they say it's a bell curve and then they give you a mean and a standard deviation. What I want you to do is I want you to draw your bell curve above a number line and then label it. The top of the hump of your bell curve is where the mean is located. It said we had a mean of 600. Then what you're going to do is you're going to go up 3 standard deviations and then go down 3 standard deviations from the mean. If my standard deviation is 53, I'm just going to add 53 up 3 times. So 653, 706, 759, I think. And then subtracting it, this would be 547, 490, something, 494, I think. And then 441. Definitely use a calculator when doing that. Don't try and do it in your head like I just did. But the reason I like doing this is it kind of maps it all out for me, and it helps me see the distributions a little bit better. So remember from the empirical rule that in between the first standard deviations is 68%, in between the second standard deviations is 95%, and then in between the third standard deviations is 99.7%. So for part A, where it's asking what is 99.7% of the distribution, that's going to be in between the 441 and the 759, the third standard deviation to the left and the third standard deviation to the right. Okay, let's look at part B. Assuming the data are bell-shaped, determine the percentage of light bulbs that will have a life between 494 and 706. 494 is here at the second standard deviation to the left. 706 is here, the second standard deviation to the right, and we automatically get that in between the second standard deviations is 95% of the data. So that's going to be the answer to part B. Part C, a little bit more difficult. So part C, what percentage is in between 547 and 706? 547 is the first to the left, 706 is the second to the right. So we are not going to be able to do one of our classic empirical rules here. We have to get a little bit more clever. And there are 2 different ways to do this. So let me pause the video and find the picture in the book. Okay, so this is on page 132 in your book. If you don't have your book yet, I know there's been some issues with the bookstore. You just take a picture of this. But you can use this picture on the test, right? You guys are going to have access to your book, your notes, pretty much everything whenever you're taking the tests. What this does for us is it breaks down the empirical rule into all the different sections of the standard deviation. So if I go back over to my picture here, see if I can get both of these on the same page. I'm not going to be able to. It's going to be awful looking. You'll just have to kind of, I'll do this really quick. Oops. Remember that for part C, I think we were at the first standard deviation to the left and the second standard deviation to the right. If you want to find the percentage that is in between those, just add up all of the percentages in this picture. The first to the left, I go 34% plus another 34% plus a 13.5%, and now I'm at the second standard deviation to the right. So if I just add up those 3 different things, I get 81.5, and that's going to be the answer for part C. So 5C, 81.5%. Okay. Cool. So if you need to, take a picture with this with your phone. I'm going to pause it and go back to the question itself. Okay. So finally, the last question here, D. If the company that manufactures the light bulb guarantees to replace any bulb that does not last at least 441 hours, then it asked what percentage would they have to replace. Okay. So if the company that manufactures the light bulb guarantees to replace any bulb that does not last at least 441 hours. 441 is way down here at the third standard deviation to the left, and we want it to not last that long, so we want it to be in this section. If you go back to the picture, they do have a percentage that is to the left of the third standard deviation. That percentage, I think, is 0.15%. You'll have to go back and double check, but that's off of memory. So I think that's going to be our answer here. 0.15%, so less than 1% of light bulbs would be replaced if they had this guarantee. All right, I'm going to pause this video or end this video, and I'll make a second part just doing more examples from this review.